So anyway, let's get started in here. I'll begin with a word of prayer. And again, if you didn't finish all this quiz, it's really okay. This was not enough time probably to do the quiz.
I was stuck on some of the problems as well.
Oh, you got stuck. Well, getting stuck, that's good. That's good. So now we know what to work on, right? I'll begin with a word of prayer. Dearly Father, we thank you for this day. Again, I thank you for this class and for this time we have to meet together. Help us to glorify you in what we do, and just that all the students would gain some valuable knowledge from this time, Lord. In your name I pray, Lord Jesus. Amen.
Amen.
All right, so yeah, here's the solution. So hopefully, by the way, my solution to, and of course this is actually your quiz 9. The numbering is from the spring. My apologies. So the solution I showed you guys to the last quiz, it had a mistake in the first problem, and I have corrected that. I'll be reposting the solution sometime probably today. So the correct solution to the previous quiz will be posted so you guys can see that. I changed I made a sign error. I changed like a plus to a minus in problem 1, and you guys didn't call me out on it when I did it in class. So it's on you now. The next section caught me. So they're just more interested in me being wrong, I guess, which is a good thing. So the first problem here, we use the let's see here what goes on. So addition puts the things in the numerator, 17 times x plus 2, right? And then this minus puts it in the denominator, and then this 3 gives me that power 3. All right? There it is. All there is to it, that one. Problem 2, simplify the following expression by expanding the logarithm. So I started with the step of just plus for the things in the product in the numerator, and then minus the denominator. All right? There's nothing you can do to that. It is what it is. This, on the other hand, is the natural log of the exponential of something. But remember, natural log and exponential are inverse functions, so that simplifies to 2 times x minus 3. And then in the front, the first one here, where I can pull the 3 out by the power property of the log. All right? Now, we haven't talked a lot about graphing. Probably we should talk more about graphing. I'll probably do that another day. But here's one anyway. So 2 plus 3 to the x. So basically, it's got a horizontal asymptote at 2. Just basically, you take the 3 to the x graph and you shift it up 2. Natural log of x plus 6. That's the natural log graph shifted 6 units to the left. So the natural log has a vertical asymptote, which is the y-axis. So this one has a vertical asymptote, which is the minus x equals minus 6 curve, like that. But there you go. It's just that. We probably all need to work on graphing, right? Probably.
Yep.
We'll do more graphing another day, okay, guys?
Deal.
Deal. All right. So here, oh man, what's going on here? This is actually the kind of problem I wanted to talk about today once we get past the quiz. This kind of thing, kind of an applications problem. So we're given a formula. A of t is 5 plus 2e to the minus 0.3t. We're supposed to find the time t for which a of t is equal to 6. So how do you do that? Pretty simple. You just put 6 equal to your formula. All right? And then we have an exponential equation which we can try to solve. This equation, actually, I don't think I did a lot like this yet, but it's pretty simple how to get it. You subtract 5 to the other side, which gives you 1, and then divide by 2, which gives you this half. All right? So goal number 1, isolate the exponential. Once you've isolated the exponential, we can take the natural log of this equation. It gives me natural log of 1/2 is natural log of e to the minus 0.3t, but remember, natural log and e are inverse functions, so this simplifies to minus 0.3t. And then I solve for t, which gives me natural log of 1/2 divided by minus 0.3. The natural log of 1/2 is, I think, like minus 0.693, something like that. So minus 0.693 divided by 0.3 ends up being 2.310. So there's a problem kind of sort of like this around like problem 101 or 102, 103, 104, 105, somewhere in there. Similar to that. Next here, we've definitely done problems like this in class. Solve 2 to the x equal to 5, so I would advocate taking the natural log of both sides. I bring the x out, we get x log 2 equals log 5, which gives me that x is equal to the log 2 over natural log of 5 over natural log of 2. Did anybody solve this a different way? Anybody in here get a different answer? The other obvious way to solve this one would be to take log base 2 of both sides. See, I could take log base 2 of both sides, and if I was to have done that, let me show you what it looks like. So we've got 2 to the x equals to 5. So if I take log base 2 of both sides, that tells me that x is equal to log base 2 of 5, right? But notice, by the change of base formula, that's the natural log of 5 divided by the natural log of 2. So you could have gone either way there. Any questions about that? You're like, well, on the test, do I have to use natural log or could I use log base 2? The answer is yes. You could use either. I know how they're related. I will count both as correct if they're correct. So, all right. Let's see here. So, next up here we have the log of x minus 1 plus the log of x plus 1 equal to log 3.
Natural log.
Oh, it's plus, not minus. I thought I had minus there. Oh, natural log, yes. So I use the property of logs. That's the natural log of the product, x minus 1 times x plus 1. And then the one-to-one property. If you don't like the one-to-one property, you could exponentiate both sides. Anyway, however you slice it. Come on. Man, I got to get some new lasers. I get x minus 1 times x plus 1 equals to 3, which gives me x squared minus 4 equal to 0, which factors to give me either x equals to 2 or negative 2. Are they both solutions? Is one extraneous? What do you guys think? One solution. 2 is the solution. Minus 2 is extraneous because if you try to plug in minus 2 into these guys, you get negative numbers. And we can't take the log of a negative number. Natural log of a negative number is not defined in this class. I mean, if you guys want me to, I could tell you about how to take the natural log of a negative number. I think we have enough time. I could develop how. Well, if I teach it. No, I won't do that. You guys won't even let me teach calculus, so you can't do that. Try and stick to the college algebra. Fine. And this one here, we've solved problems. Come on, laser. You have one job. You have one job. All right, e to the 2x minus e to the 3. So this one, it says make a substitution. Either you could let like y equals e to the x. You'd have y squared minus 3y minus 4. I just decided to factor directly in terms of e to the x here. See, this is e to the x minus 4 times e to the x plus 1, which either gives me e to the x equals to 4 or e to the x equal to minus 1. All right, one of the very important properties of exponentials is that they're positive. You can't get 0 out of an exponential, and you can't get a negative number out of an exponential. And as such, there's no solution to e to the x equals to minus 1. On the other hand, e to the x equals to 4 has solution x equals log 4. So there's that. So any questions? Yep.
So if we did that one a different way but got the same answer, is it okay?
Oh yeah, if you did it a different way but got the same answer, I'm happy, probably. Unless you got incredibly unlucky with like having a wrong answer with getting right work, that would be my classification of unlucky here, but that seems unlikely. Let me look. This I can include in my math prank channel. This is not correct work. But you did get the right answer. That's funny. That is funny. Man. Wow. No, I mean there's an incredible consistency to what you're doing. I'm hesitant to even show the class because if I show them, then you know what's going to happen. I mean, so this is actually really cool, but it's wrong. But it's also so let's see if I can recreate the magic here. Equal to 4, right? So I believe what you did was you took the natural log, right? And so you're like 2x ln e minus 3x ln e, right? Equals to 4, oh no, ln 4, right? And then, well, this is 1, and that's 1. That's true. And but how did you get a plus? Did you get a plus? Did you just make this plus? How did the minus? I missed.
I don't know. Good question. I don't remember what I did.
Oh, okay, cool. So then you just did this. Which is, I mean, I would say from the step above, I would be minus x equals log 4. So but this is actually a very productive discussion because what's almost as important as what we can do is what we can't do, right? What can't we do here? There are aspects of this calculation which are totally legitimate, in fact good. There are others which we can't do. The main thing that's driving the solution, I believe, is the idea that if I have the natural log of e to the 2x minus 3 e to the x, that's equal to the natural log of e to the 2x minus 3 times the natural log of e to the x, right? That's the underlying idea you're using, right? And then this step here, 2x log e minus 3x, which is altogether minus x, that's actually, this is okay. That part's okay. Actually, none of this is okay. What am I writing with? This hideous Carolina blue. It's disgusting. However, just exactly the right color to write incorrect mathematics with. I should always make errors in this color. So anyway, this is just not true. Like the natural log of a sum is not the sum of the natural logs. There is no such property. It is just not the case that the natural log of a plus b is like equal to the natural log of a plus the natural log of b. This is not true. Strike this from the record. Remove this from your collective psyche. Do not do this. There you go. That's not allowed. So sorry. So yeah, this one. So yeah, this is an example of a problem where just taking the natural log of the equation, it won't work out for us. We have to do that quadratic thing that I did on the solution, all right? But nevertheless, there's a lot of what you were doing which was correct. Like once you made this, your initial wrong step, past that, your simplifications were good. So, signs of life. Yes. So I hope that you all have discovered that you understand part of the material at least, but maybe not all of it. And so try to focus on the part you don't understand and fix it, all right? Don't be like me. When I was undergraduate, I'd taken a class and I was studying for a test. So oftentimes what I would do is I would spend the lion's share of the time studying the part I already understood. Because it feels good. I know this. I got this. The other part that I don't know, I'm gonna put it off. I'll get to it. I'll get to it later. And then what would happen, of course, is I would get to it at 2 in the morning and the test's at 9. And it just doesn't work out, right? So it's better when you find out that you've got an error somewhere, you should focus your attention on where the error is to try to fix it, right? Now some of you are like, well, I make mistakes on everything, so what's your point? But no, I reject that. There is something you're making a mistake on. Focus your attention there. Oh, and let me erase all this before any of this. Yes, do not, these are bad, not true. Bad algebra. All right. So, I want to talk to you guys about how to solve problems that are kind of like the middle problem on that quiz. So, example 1. What if we have something like 3 to the x is equal to 2 to the kx minus 1? Oh, actually, I'm not sure that's even, I don't even know. Actually, I think as I have it currently written, I don't think we can even, I'm not sure I can even solve that. Let me not put this minus 1 here. I have a bad feeling about that minus 1. All right, so here's the question. Can you find k? Can you find a value for k such that this equation is true for all x? Do we understand the question? Can you find a k such that this is an identity? An identity is something that's true for all x. All right? So, any ideas? I know 2 solutions to this. The one solution is the super sneaky, clever solution. Yeah.
ln 3 over ln 2 equals k.
Ah, Michael knows the solution. Michael says, take natural log of the equation. Michael is correct. That will solve it. What's the difference between this one and the one that the natural log didn't work on that problem I was just discussing? Do you know the difference? The difference is that this one doesn't have a sum of things, right? Whenever you've got like 3 terms involved, and you're taking the natural log of 3 things where 2 of them are added or subtracted, you're probably not doing the right thing. Then we have x log 3. We pretty much have to have a product of things or a quotient of things to take logs. X log 3 is equal to kx log 2. This is true. We want this to be true for all x, right? So we can divide by x then. All right? So this tells me that log 3 is equal to k log 2. Aha! Apparently k is the natural log of 3 divided by the natural log of 2. There you go. Would you like to see my super sneaky other way to solve this?
Sure.
All right.
Oh, I mean, yes, no problem.
Okay. Okay. So the other way I would do this is to notice that 2 to the kx is equal to 3 to the log base 3 of 2 to the kx, which is equal to 3 to the k times log base 3 of 2. I'm sorry, kx log 3. Let me get out of the way here. Kx times log base 3 of 2. But you see that's equal to 3 to the x, which tells me that kx log base 3 of 2 is equal to x, which tells me that log k is equal to 1 over log base 3 of 2. Now that answer looks different than the answer we got, but why are they the same? What's the change of base formula?
Log of x equals,
How can I change to the natural log? This would be the natural ln of 2 divided by ln of 3, right? But that is equal to the ln of 3 divided by the ln of 2. So here's a different and possibly weird way to do it. I bet you guys like Michael's solution better, right?
A little bit.
That's fine. I think I like Michael's solution better too. All right, so another problem that we should look at is something like we have P of t is equal to, let's say, 100 e to the minus kt. All right? And that is equal to, let us say 100 times, my bad, 100 times 2 to the minus t. And I still haven't stated this correctly yet. I'm sorry, guys. I'll get to it eventually. Instead of minus kt, let's put minus t divided by what's called tau. Sorry, Michael. Tau is a Greek letter. Tau. So the question here, oh man. I'm sorry, I don't think I've set this problem up right. Give me a second here. I'm trying to do something kind of sort of like your homework, but I think I remembered the formula a little bit twisted. Hey, you be quiet. So I was trying to do something kind of sort of like problem, I'll find it eventually. Oh man, did I just solve problem 103?
Thank you.
Phew, I did not. It was close though. It was close.
It is. No, it's really close.
It's really close. The 2 and the 3 are flippity flopped.
See, you gave us close.
Yeah, you can pretty much take my solution and twist it a bit. All right, so sorry guys. This is like 104. So 104 has something like this. P of t is equal to 20 e to the minus, let's say, 3t. All right. And I say if P of t is equal to, let's say, 20 times 1/2 to the t over tau. I know it's hard to see the difference between my t's and tau's, but divided by tau multiplied by t, then what is the value of tau? All right.
Does that say Zoe or 20?
20. Okay, so what we have then is we've got 20 e to the minus 3t is equal to 20 times 1/2 to the t over tau. So what's the first thing you can do here to make your life easier? We're trying to figure out what tau is. And this is a lot like the previous problem in the sense that we're looking for an identity. So it's going to hold for all time. Okay? So I can divide by 20. I would suggest that's a good opening move. And I would also suggest that I probably should move the camera. I get too carried away here. I don't think people missed much yet. It's good. All right, so divide by 20. And then what do you guys think I should do? Michael might know the answer. What do you think, Michael?
ln½ over -3 is the value of tau.
You're just telling me the answer. I want to know how to do it, though.
I do.
You already did it, okay. So we take the natural log of the equation. Natural log of the exponential just gives me minus 3t. And that's equal to t over tau times the natural log of 1/2 by the properties of the log. See, I can pull the t over tau out, pull the power out. Then just divide by t. That gives me minus 3 is equal to the natural log of 1/2 over tau. Let's improve this a little. Can you guys tell me how to simplify the natural log of 1/2? What is the natural log of 1/2? This is natural log of 1/2.
-0.693.
That is true, Michael, but I'm looking for, that's the natural log of 2 to the minus 1 power, which is minus the natural log of 2. See, so this is actually equal to minus the natural log of 2 divided by tau. And solve for tau. Tau equal to? Let's see here. Natural log of 2 divided by 3. Can you guys tell me what the significance of this is? What's the significance of tau? What is tau called? Try this out. The half-life, that's right. So if we look at p of 1 tau, we get 20 times 1/2 to the tau over tau, which is 1. If we look at p of 2 tau, we get 20 times 1/2 squared. So after 1 time constant, we get 10. After 2 time constants, after 2 time taus, we get 5. If you went to 3 time constants, 3 times tau, you would get 5/2. So after you go from time 0 to time tau, every time you go that much time forward, if this is population, your population halves. So this is called the half-life. If it goes the other way, if instead of having a minus 3, we had a plus 3, we would end up having 2 to the thing. It would be the doubling time. Yes, Michael?
So how did you get -3 on the top? -ln2.
Because natural log of 1/2 is minus the natural log of 2. They're equal.
Oh.
Yeah.
I see that.
Yeah. So my final example for today is Newton's law of cooling. So example 3 here. Newton's law of cooling is something like this. In the homework, I did it like this. K of T is R plus A e to the, I think minus KT is what I did. This is Newton's law of cooling. So this formula is interesting. So I'm using big K as the temperature. All right, so what this is, the temperature at time T is equal, yeah, R is the room temperature. What happens with this formula, if K is positive and T gets really large, what happens? Well, the A e to the minus KT term goes to 0. So the temperature just goes to room temperature as T goes to infinity. So the significance of this constant here is room temperature, or sometimes the ambient temperature. All right? So there's a problem in your mission 3 where I tell you that the room temperature is 70 degrees, all right, Fahrenheit. So what that means is you put 70 in for R, all right? And you kind of go from there. So like if the room temperature, if it was, if this is equal to 70 degrees Fahrenheit, let's say, that gives us K of T is 70 plus A e to the minus KT. How much information do you need to know in order to solve one of these problems? Yes, Michael?
The starting temperature of a drink.
Yeah.
And the A.
The A, yeah. So Michael's right. Let me just let's look at this formula, just appreciate what's going on here. How many parameters define Newton's law of cooling? You've got a room temperature. You've got this A here, which has somehow to do with the initial temperature of the object that we're talking about. And then you have K, which is describing how fast the object loses heat to the surroundings. So you actually have 3 independent constants to describe Newton's law of cooling. So in order to solve a Newton's law of cooling problem, you need at least 3 independent pieces of data just to write down the formula. And typically these problems are given with a 4th thing, which is to find the temperature at some future time. So basically the way these problems work is you use the data that you have, that you're given, to find the R, the A, and the K. Once you have all those, you set that formula equal to whatever future temperature you're looking for. Listen, it takes me about 10 minutes to solve this problem. I just wanted to get us started on it for today. We'll come back to it Friday, okay?
How did I do today?
Very good, Michael. Michael's cracking me up. All right, here.